Earthquakes are one of the most destructive natural disasters that can strike anywhere in the world, and they can cause enormous damage to buildings and infrastructure. Some of the most destructive earthquakes in history include Shaanxi earthquake, China, 1556. Great Kanto earthquake, Japan, 1923. Tangshan earthquake, China, 1976. Haiti earthquake, Haiti, 2010. Tohoku earthquake and tsunami, Japan, 2011. These earthquakes are just a few examples of the devastating impact that earthquakes can have on communities and nations.
Hi everyone, and welcome to Shazy Crazy channel and our video about earthquake-proof building structures. There are ways to design and construct buildings that can resist the forces of an earthquake and protect the people inside. In this video, we'll explore some of the most innovative and impressive earthquake-proof buildings from around the world, and see how they work.
Advancements in earthquake-resistant building design and early warning systems have helped to mitigate the damage caused by earthquakes. The threat of earthquakes remains a serious concern for many parts of the world. There are ways to design and construct buildings that can resist the forces of an earthquake and protect the people inside.
First, let's talk about the challenges of building in earthquake-prone areas. Earthquakes can produce several types of seismic waves that can shake buildings in different ways. These waves can cause the building to sway, twist, or vibrate, which can lead to structural damage, collapse, or even total destruction. To prevent this from happening, architects and engineers have come up with several strategies to make buildings more earthquake-proof.
One of the most common strategies is to use base isolation. This technique involves installing special shock absorbers, or isolators, between the foundation and the building. These isolators can absorb the energy of the seismic waves and reduce the amount of shaking that the building experiences. One example of a building that uses base isolation is the Tokyo Skytree, the tallest tower in Japan. The tower has a giant concrete ball at the base that acts as a counterweight and is surrounded by oil dampers that absorb the seismic energy.
Another strategy is to use a system of steel or reinforced concrete braces that connect the building's floors and walls. These braces can help distribute the forces of an earthquake and prevent the building from collapsing. One example of a building that uses braces is the Transamerica Pyramid in San Francisco, which has a distinctive triangular shape and a steel frame that can sway up to 16 inches during an earthquake.
A third strategy is to use a flexible, lightweight material for the building's exterior walls, such as steel mesh or fiberglass. This material can bend and flex during an earthquake, reducing the amount of force that the building experiences. One example of a building that uses this strategy is the Taipei 101 Tower in Taiwan, which has a steel frame wrapped in a skin of steel and glass.
Tokyo Skytree. The Tokyo Skytree is the tallest tower in Japan, standing at 634 meters.
Taipei 101. Taipei 101 is a 101-story skyscraper in Taiwan that was completed in 2004.
Burj Khalifa. The Burj Khalifa is the tallest building in the world, standing at 828 meters.
Marina Bay Sands. The Marina Bay Sands is a 57-story hotel and casino complex in Singapore that was completed in 2010.
Petronas Towers. The Petronas Towers are a pair of 88-story skyscrapers in Malaysia that were completed in 1998.
Each of these buildings has its own unique design and approach to earthquake resistance, but they all share a commitment to protecting the people inside from the devastating effects of earthquakes.
We hope you found it informative and interesting, and if you have any questions or comments, please leave them below. Thank you for watching, and we'll see you in the next video.